Hey everyone, it's Mrs. Brimlow, and today we're going to be talking about a special type of relations. And before we get into it, I want to start by talking about a vending machine because the type of relation we're going to talk about today is very similar to how a vending machine works. So, if you go to a vending machine to buy a snack, you have to pick your snack, see how much it's worth, you put in the money, you put in the code, and then hopefully, if it works, you get your snack. So, for example, if I wanted to get this Hershey's with almonds, which is something that I love, I can see that it is 70 cents and I would need to press A4. So I'd put in the money, I'd press A4, and then I should get a Hershey's because the computer system will register that's what I want. Now, if I want to get a Three Musketeers bar, if I click A4, am I going to get a Three Musketeers? No, I'm not. So, whatever code you punch in is what item you're going to get out of it. And it's the only item you can get out. So, if I want Teddy Grahams, I'm going to type in B3. And that's the only snack I can get by typing in B3. The computer system does its work and then it gives me the snack that I want. So, like a vending machine, the type of relation we're going to look at, which is what we call a function, you put something into the rule, or in this case, a machine, and then you get one specific item or output. Okay. So, you should have a copy of the notes. They're also linked in Canvas. And we're going to go ahead and get started. There's a space for your name at the bottom left where the gear is. So, a function is a relation with one or more variables where each input has a single output. So, like a vending machine, I can only hit a button and get one snack. If I get more than that or different snacks, there's something wrong with it. It's broken. Be great for me, but there's something wrong with it. So, a function is a special relation where each input has one specific output. And if you think of a function like a machine, like the vending machine, what we put into that machine is the domain or x values. It's also called the independent variable. Okay. Or it's called the input. Okay. So you put it into the machine, which in algebra is a rule or an equation. And once you work with the rule, you get your range, your y values, or it's known as the dependent variable. Your y is going to depend on your x. It's also the output of your machine. Okay. So once again, for functions, each x value is only allowed to correspond with one y value. Now, each y value could have multiple x values. Okay, I'm going to say that one more time. Y values can have multiple x values. X values can only have one y value. Okay. Now, you can go ahead on your notes and cross out these two sections here. We're not going to be talking about those. And I am going to be using two different highlighters to talk about these two tables. So in this first table, we're going to determine if it's a function or not. So each x value should only be used one time. So 0 to 0, 1 to 3, 2 to 6, 3 to 9, 4 to 12. So it looks like the rule is whatever x is, you multiply it by 3 to get your y. So no x values are repeated and used with two different outputs. So we're going to go ahead and highlight that this relation is a function because none of the input values has more than one different y value. Okay, so each of those x values is used once. Now in the second one, we have -3 to 1, 2 to 5, -3 to -1. I can stop here because there's already an issue. -3 goes to 1 and -1. Those are two different numbers. -1 and 1 are two different numbers. Therefore, this is not a function. Just grabbing a different highlighter. Okay. So this relation is not a function because at least one input value has more than one different output value. And that's all it takes to not be a function. Is it a relation? Yes, it's still a set of ordered pairs, but it's not more specifically a function because I have an input value being repeated. Okay. That's like hitting -3 on a vending machine and getting out Reese's and a Three Musketeers. Great for me, but there's something wrong with the machine then. Okay. So when we put something in, we can always expect a consistent result to come back out based on some rule. So if you could flip to the back. Okay. Now, yesterday we talked about relations, and as mentioned earlier in this unit, a function is a relation. It is a specific type of relation. So they can be represented in the same ways as a relation can. So starting with a table, we're going to look at determining whether a relation is a function, okay? So when we're looking at a table, we review the columns. The relation will not be a function if any x value corresponds to more than one different y value. So we have two tables here we're going to take a look at. So I have -1, 0, 1. I have no x values repeating, so I don't have to worry about it being used twice. So this would be a function. So you can color in or highlight that y. My second one, I have 3, -6, 0, 1, and 3, 6. So notice 3 is being used twice, going to -6 and +6. Those are different numbers. Therefore, 3 is being used twice for two different outputs. Okay, so that would not be a function. Another way we can look at relations and functions is set notation or ordered pairs. So we're going to look at each ordered pair. The relation will not be a function if any x coordinate corresponds to more than one different y coordinate. Okay, so as a reminder, x always comes first, then y. So I've got 3, 4, 2. None of those x values are repeated, doesn't matter what their outputs are, so this would be a function. I've got 1, 0, 1. Now, because 1 is being repeated, I need to look at their outputs. So I have 8 and 3, -3. Those are two different numbers, so that is not a function. Once again, that's like hitting 1 on a vending machine and getting out two different snacks. Great for us, something wrong with the machine. Now, when we're looking at the graph, we use what we call the vertical line test. The relation will not be a function if a vertical line ever passes through more than one point. So in this first function, if I was to draw vertical lines through this graph, you can see it's only hitting the graph once. So this is a function. Okay. So in this next one, if I start where the graph starts, so that's hitting once, but when I do my second line, it's hitting twice. And the points it's hitting at, it looks like -1, 2, and -1, -2. Notice -1's being used twice, but with two different outputs. And I can see that's going to happen multiple times with this graph. So this would not be a function. So vertical line means up and down. And for the test to work, it can only hit the graph once when you draw vertical lines through it. Okay. Last but not least, we have our mapping diagrams. So we review our arrows. The relation will not be a function if any x value maps to more than one different y value. So basically, you only want one arrow coming from each x. So I start with -4, only has one arrow to 16. -2 goes to 4. -1 goes to 1. 4 goes to 16. Now, even though -4 and 4 are going to the same output, that's okay. That's like going to a vending machine, and if you hit B4 and B -4, they both have almond joys. That is possible. What we can't have, so this would be a function. What we can't have is in like this one, and I want you to circle this number, which is 3. Notice 3 is going to 4 and to 16. So once again, that's like hitting one button and getting two different stacks. That's a problem. So this would not be a function, okay? All right. So as a reminder, the domain is the set of all possible x values, or input or independent variables. The range is the set of all possible y values, okay? Just a review from yesterday. So if you're at home, there's an IXL strand for you to work on. If you're in person, you're going to be doing a sort, and I will go over those directions. If you have any questions, let me know, and I will chat with you soon.